This is a step-by-step guide on building a pusher-style Delta Wing, and it's geared towards first-time foam builders. I don't speed up any of the video, as this often glosses over a step that experienced builders kind of know by heart, but new foam builders just it kind of throws them off, and they kind of feel like they're missing something. So be prepared in the video that there's long periods of silence, me not speaking, and I've muted the background because it's kind of noisy where I'm at. But I will put some chapter marks for easier navigation. The overall goal for this build was to make something that was inexpensive, easy to build, easy to fly, and durable and repairable. And especially if you fly this with a stabilizer, you almost can't tip stall it. It will just self-correct by simply just letting off the sticks. This is a modified version of the 36-inch Raptus wing. This is designed for FPV combat. I saw it flying super slow. And I was like, "God, this seems like a good one to try to build." The intention was to limit the wingspan specifically to 30 inches, so that you could fit one piece of the base of the wing on a single piece of Dollar Tree foam board, while the whole thing could be built using two pieces of foam board. I wanted simple to angles and easy to measure and easy to understand cuts and no folding as a foam board. So I opted to go with what's called a KFM2 airfoil, which is essentially the root chord, which in this case is 20, which is the length of a Dollar Tree foam board, and the tip chords, which are 6. And so it's 50% of each one of those. And I'll go through how you kind of measure those in a second. But again, the overall cuts or dimensions for this are, so the root chord there is 20, the tip chords are 6, the elevons are 10 inches by 2 inches, there's a 3-inch fuselage, and then the motor, see where the motor sets, where it mounts to is 6 inches off basically the bottom of the wing, and then that space that you see there, it's 8 inches wide. So this will accommodate, I think I'm flying with a 5-inch prop, but it'll accommodate easily up to a 7-inch prop. So it's got a wide range of motors that you can put on this. I just like this particular motor because it gives plenty of power. They're pretty cheap, and you know, the bigger the prop, it's a little more noisy in my opinion. So all in all, you know, I think this wing is super easy to build. It's again really durable, and I use inexpensive parts and 3D printed parts that you can get for free to build this. So with that, I'll move into these I guess the specific components that I selected for this, right? So I'll start with the build materials. So the build materials are essentially 2 sheets of 20 by 30 foam board, and that's about $2.50, $2, something like that. An X-Acto knife, hot glue, Velcro, wood screws, tape, plans. You know, a lot of those things at the bottom, like the popsicle sticks and Velcro and zip ties and rubber bands, are all kind of optional, but they kind of make this a little tidier. From an electronics perspective, I will kind of cover some of the cost here. So motor's an RS 2205, it's 2300 kV. The prop is a Dal Prop 5040 4-blade. The ESC is a 30 amp. Servos, I got 2 9-gram Metal Gear, and then the receiver is an HRLC ELRS 2.4 flat antenna. I like this because it's pretty durable. The grain change isn't the best, but it's great for this in case you wreck or crash. The stabilizer is a Bime D10, and then the battery is, you can fly, it flies on the 3S 1300 to 2200 or a 4S 1300 to 2200. My recommendation is the 4S 1300 to 1600. It's light enough, but it gives power where you really don't even have to fly this thing much above 30 or 40%, or actually 20%. But you want that extra power, like when you're getting into like tight curves and being able to punch out of it. But it's not a speed demon by any means. So at higher speeds, it's going to it's not the best. And then 3D printed parts I've got control horns from the S800 Sky Shadow, and then a motor mount, and this is a spec wing motor mount, modified push rods. And you either you buy them if you have them, or just modify them using paper clips and that sort of thing. So your total build cost is going to really depend on what you go with in terms of batteries and what you already have on hand, right? I think I basically had everything to build this on hand. Yeah, yeah, pretty much. I had these were basically spare parts that had come off the other stuff. So for me, the only new cost was the additional foam board that it took. But your total cost is probably going to vary quite a bit. So
The first thing I'm going to do is measure out the wingspan, which is 30 inches. A dollar sheet of foam boards, just slightly less than 30, so it's like 29.9. So I kind of take the mark right before the 15-inch mark, and that's pretty close enough for halfway. Now I'm going to draw the center line, and this pretty much starts as the base of all of the most of the other cuts and lines. So what you're gonna see me do is mark off various lines across the bottom that go out to 8 inches. So I think I'm going off to it's a I go an inch, and then an inch and a half, and then 2 inches, 3 inches, 4 inches, and then what that allows you to do is to draw straight lines across the wing. So it's easier to make cuts. So it leads you to do the fuselage. Uh, so the fuselage is going to be 3. So that should be, I think it's the first one that I make, which would be an inch and a half off to the side. I think it's if I got it remember correctly. So the main things that you're going to measure with this is it will serve the center line will help you draw the KFM airfoil, the second part on top. It's going to help you have a straight level for a straight cut for your where you cut out the motor mount in the back, and it'll also help you get to the the get up the exact 6 inches from the back so you can do the motor mount. So this is a kind of a key piece of that makes the measurements simpler later on. It makes this an easy build. So part of what makes this a relatively easier build also is the fact that the wings go all the way to the back to the bottom of the board, right? So you don't have to kind of move up and draw through the back of the fuselage or anything like that, and then cut it out. You can just they go straight to the all the way to the back. So it's in my opinion, it's what makes this wing pretty easy to build. These kind of drawing these lines out's probably been the one of the things I've done that I've learned over time that's probably helped out the most. I used to kind of have a bunch of cuts that weren't square, things that didn't line up, but this helps that out tremendously. So what I'm doing here is I'm highlighting the main area of it so it kind of stands out on paper of the center line. Sorry. So now I'm going to measure the area for the wingtips. So this is going to be for 6 inches. Now again, right now I'm only drawing when I draw the lines, I'm kind of only drawing the lines for the base wing, not the KFM2 airfoil. Okay. Clearly you can see what I did here as I forgot to draw the inch and a half mark on each side for the fuselage. So that's what I just did there. And now for the other side. So where the fuselage lines come in handy is when come into play is when you actually draw the wing. Because this wing has a fuselage, the leading edges start at the edge of the fuselage and then go to the root cord, or excuse me, to the tip cord. So you're essentially on this right hand side, you're up 6 inches for the tip cord, and then you're going to take that up to the uh, the fuselage, and on that side it's 1.5 inches over from the center line, and it's going to be the same thing on this side here, 1.5 inches over, and then take that all the way down to onto the left side, which is 6 inches up from the bottom. Again, having these kind of measurements that are straightforward, where you don't have to kind of go, start removing um, for the Elvons. This makes one of the things that makes this easier than some of the other builds I've tried, foam board builds I've tried. Okay, so now what we're measuring here is, remember the root cord is 20 inches, and so the KFM to airfoil is going to be basically 10 inches by 3 inches for all practical purposes. Oh no, I take that back. This is yeah, this is going to be, I'm measuring for COG. Sorry. Now what this allows you to do is to take your COG all the way across the length of the plane, so then it doesn't really matter where you put your kind of marks. Once you cover it, like once you start adding tape or anything else you want to do to it, right? You can extend this line all the way across the plane. So all this looks like the top of the plane. I'm actually kind of drawing the bottom of the plane, mainly so I can see all of the marks when I'm done. Okay, so here I'm measuring up 6 inches from the back, and I'm going out 4 inches to the side. So what we're getting ready to do, what this is going to be, is the cut marks to cut out for for the motor to go in. So that line there is 6 inches up from the bottom, and it's 8 inches across. So 4 off to the right and 4 off to the left. So all I'm doing here is I'm just basically going to take a marker here to make it easier to see on video the actual line, what the outline looks like. And same thing down here. These are going to be these are going to be the major cutouts for the wing, so they kind of stand out from all the other kind of marks. Okay, so now I'm going to draw out the elevons. So the elevons are 10 inches by 2 inches. So I just have a blank a piece of I think it's 2 inch by 4 inch that I use to do this and kind of get the basis of a straight line. And it's just easier than trying to match up the ruler or the yardstick and then try to do this and get the corners to be 90 degrees. So you don't have to do this. You can just use a regular ruler if you want to. But again, I made so many of these. I kind of have a bunch of these different size blanks, 1x3s, three by sixes, 4x8, so 1x6, well, all those within like half inches, right? So I can use those in a lot of different areas, and this speeds up the measurement process. Um, so now I'll just finish this here and make the final the main cut line. And so I'm right in the inches, so it's 10 by 2, and the elevons go all the way to the tip cord. And then what I'm leaving here on just outside of where the elevon falls short is that way in the end you'll see where the vertical stabilizers connect to it. So I misspoke earlier. Here's what I'm going to draw for the KFM airfoil. So again, the root chord's 20, and so half of that is 10. So I'm using 50% of the base wing for the KFM airfoil. So that's 10 inches. It doesn't really matter, you go up or bottom. And then the tip cord for the base is 6 inches, and so you're going to do half of that, which is 3. Now you just basically connect the 3 inches from the tip cord to the 10 inches for the root cord, and that basically draws the outline for the um, for the KFM airfoil. There's a couple ways when you do the KFM airfoil. You could do it. You could measure it separately. It's probably takes up less paper, but to me, this is just easiest to get it to get it straight. And it's probably quicker, so you don't have to do as many measurements. Because essentially you're going to see what happens here is I basically just do an outline and I poke through this through the base layer in order to draw the center points for the other for the KFM2. So you can see right there that's 3 inches. Same thing on the other side. Will kind of warn you that on this as this video goes on, the camera starts shifting and I can't see it. It's above me, so part of this gets cut off. But that's all that it was. I wasn't trying to hide anything. So what you see me doing here is again as I'm making the major marks for the things that kind of really matter, and so that is your 3 inch fuselage. Now I pushed that all the way through, so now I know exactly where to take the for the second sheet of paper once I do it. Once I make the start on the KFM airfoil. So a lot of doing this is just kind of having the prep work so that you don't have to go back and spend a lot of time like redrawing lines and that sort of thing. So the straight lines help pushing through the making marks through the sides or through the center. And transferring that again is one of those things, one of those techniques you can do to kind of just speed this whole entire process up. Once you've done this whole thing from start to finish, you know, you can probably do this in an hour. I'm going a little slower, double checking my measurements, and then writing my measurements down, just simply because I was doing a video. But I think normally I can do this in probably about 45 minutes, something like that. So again, so what we're doing here is we're cutting out the space for the motor mount to go. So again, it's 6 inches up and it's going to be 8 inches across. The reason you do this is what this does is it helps move the center of balance. If you had that motor clear in the back, you'd have to have so much more weight up on the front end, almost to the point where um, it would probably almost wouldn't be flyable to a certain extent, or if it would, the performance would be like greatly reduced. One thing about this wing is basically floats if it's light, so which is one of the things that makes it easy to fly, easy to launch, that sort of stuff. So here we're cutting out the marks for the elevons. So again, those go all the way to the tip cord. So you take those out, and then we leave a little bit here for the stabilizers to hook to later on. Now we're gonna cut out the other one. Now, as I'm, it's the same measurement, so no, there's nothing new here. So one of the things with if you've not done this before and tried to cut these is so you cut them and then you have to bevel the ends, right? So you can do it one of two ways. If you're it it's a little more difficult if you use the X-Acto knife to kind of bevel them at a 45-degree angle, and that's all that you use. To me, what I found the easiest thing to do is to bevel them a little bit with a knife, not be super precise, and just get a sanding block and sand them down, and then till they move freely. That's all that's really needed. It doesn't necessarily have to look to look pretty. So the other thing is to me when you sand them, they seem to have less of a chance of like peeling away from the paper as if they have a strong, like a hard cut. I think it's mainly because that it forms an easy line for the paper to lift off with. But for the purposes of your first build, it doesn't really matter. Just do what you're comfortable with. And here you can see where the camera's slowly starting to kind of move over to the side. So what I've done here is I'm pinning this thing. I'm pinning these up to the second sheet of paper. I'm just going to trace, right? So what you do is you mark the center line and then you match up the tip chords so that that the 3 inches from at the top go all the way to the base of the second sheet of paper. This will minimize the amount of paper that you use, or excuse me, the amount of foam board that you use. So now I'm just going to draw the outline. You know. Now, is this outline 100% spot on? No, but I don't think it needs to be for the purposes of this. And the big reason I say that is when you lay this on top of there, right, you're going to want to bevel the front edge of the leading edge of it. So you basically get it down there, and you can sand off the minor differences that if one doesn't fit up 100% exactly to the next, right? So now what you do is kind of repeat that similar step that you did before, where you go from the tip of the root cord to the centerpiece, right? So now we're going from now it's basically starting at 0 on the right hand side of the tip cord, and then you're going up to that 10-inch mark, which is half of 20. Right now, this may not make sense, but you'll see it when I lay it on top of the other one, how the measurements kind of come up. And okay, so that's essentially the outline for the KFM2, sorry. So there again, you see that 3-inch mark. That's again, so you can match up what you put on the other one. So now I'm just going to cut out the KFM2. It's pretty straightforward. So that's it as far as the cutout for the KFM2. Pretty straightforward. Okay, so now I'm gonna work on beveling the edges for the elevons. So see, I'm gonna use a mix of just using um, the X-Acto knife to start it, and then I'll use the sanding block to smooth it out and even it out. I think the beveling edges is probably one of the harder things, or maybe not harder, but things I was most scared to do because I always thought I was going to mess something up. You really can't mess this up. It's all kind of repairable. So if you just go easy until you get the hang of it, and then know that you can just sand most of it away, it gives you a lot more confidence to do this. So it's not most times you make a mistake with this, it's recoverable. It's not some huge problem you got to deal with. May not always look the prettiest, but don't know that that's kind of the absolute requirement here. You really only need to kind of sand these enough until they move freely. It doesn't have to be perfect. So, and you can reinforce them with tape if you want to, and usually I typically do. Um, as a matter of fact, I think in for this video, I didn't initially tape them, went out and flew it, and they got like on a day that had a little bit of dew on the grass, and so they got a little wet. So I went ahead and just taped them. So you'll see part of this when I finish it inside, it doesn't have tape on it, and then um, after it kind of landed on the water, then I kind of the paper started to lift, so I ended up taping it. So right. So now this is completely optional, um, but the way this wing is designed, when you crash, almost all of the force is going to be on the nose, right? Um, it's if you hit it on the side because it's angled at such a sharp degree, if it hits in the on the anywhere on the leading edge, the wing typically just tends to spin around whatever it is that you hit, right? But so most of the times, if you it's going to be what you'll end up doing is, especially if you're flying in manual mode, flip it over and then you'll send it going flying into the ground and you won't be able to pull out or something, and it'll hit the ground, right? So the wing overall is super strong, but just adding these little popsicle sticks underneath the fuselage will help strengthen the plane as well. And you'll see it, I think, on this when I'm done. I cut some 10-inch strips to they're 10 like I think they're like 10-inch by 3 inch the width of the maybe excuse me 10-inch by 2 inch, and so they're just slightly shorter than or less wide than a fuselage. And I run that on the top and the bottom of the fuselage, and so that also makes this wing incredibly strong without really adding too much weight. And because you're adding this thing is 2 pieces of foam thick. You really don't need a spar for the side of this, right? Most of the like if you again most of the it's doing flips and rolls like that because the wing is thick and it's wide, then like there's not much flex in the wing for when you fly it. So and it doesn't get going, you can't it doesn't really fly super fast. I mean it'll probably go 35 40 mile an hour, but you're not going to go 90 with it, right? It's just it's not very stable, or it's stable but it just burns up a lot of a lot of battery, and it really doesn't go much faster, right? So again, this wing is aimed at a relatively new beginner, in terms of its flight characteristics and its ability to build. So I'm grabbing some weights to basically hold this the top part down, um, while the glue dries or cools in this case. Now what you're looking at, remember, this is going to be the top of the wing. That's why you're not seeing all the cut marks that we were drawing over. So I've actually flipped the wing over. Now it doesn't really matter, but this is just easier for me to do it because I like having the cut marks on the bottom until I'm completely done. Because for doing things like center of gravity and all that sort of stuff, right? So, and you don't need a ton of glue. All you need this thing to do is to stay down in the beginning, right? So the less glue you use, the lighter this is going to be. So go pretty sparingly with the glue. What I did there, even though you can't see it on camera, is that because I put them popsicle sticks in there, there's a little bit of space on the front, and so I'm trying to make this again, or the edge at the where the fuselage is, to be as strong as possible. So I don't want any kind of gaps in that leading edge there. Because I've this is probably the third one I've built, maybe the fourth one. Yeah, the fourth one. In all cases, over the first two cases, I didn't use any of those popsicle sticks in the beginning, and that's at the front of the plane, and that's where all the bending and stuff occurred, right? So, and this wing again, this is taken from a FPV combat, so its design is by nature supposed to be relatively robust. You could really, I mean, if you really wanted to enforce this, you could put a spar in there. You could put basically like barbecue skewers under right in front of the leading edge, and that would also make this stronger. So for this one here, I'm going bare bones. I will tape the leading edge, but I'm not taping the whole entire plane. So again, this thing's not waterproof, et cetera, et cetera. I've got another one that I've got that I put iNav on, and it's basically taped all up. It's got a more robust kind of like fuselage. So again, it's kind of what you want to make out of it. But for simple beginner, easy flying line of sight, slow, I mean, you can high alpha this thing with no problem, especially on 4S. For me, this is probably, man, I don't know. I bet I've probably built 30 foam planes over probably like the past 2 years. Um, I started with the experimental airlines version where they did the arm and folding wing, and then which those are they're easy. The actual regular straight wing is pretty straightforward to build. I always had problems with doing the fuselage and folding it up, so I moved away from doing that and just went to kind of cutting them. And then the other kind of ones I kind of did a lot of were the Speed Demon by Joshua Finn, which is, I mean, those are fast. It's a fold, but the fold's more complicated. And then I did um, I moved away from just doing folded fuselages to strictly just gluing them out. Is the result was much more predictable. And then the problem I had with the folded fuselages was they would tend to buckle, and the paper would start to remove where you did the bends. So here, what you see me doing is it's basically starting to do the same thing I did with the elevons, and I'm beveling the edges. So again, I'm not overly concerned of the um, you know, how good this looks when I get done with my first kind of pass with the X-Acto knife. Um, it One of the tricks you can do, and it would be hard for me to show this on video anyways, is you can take a pick a pick a length or a width of say like a ½ inch, right? And you can basically use a ruler and set the ½ inch mark and draw a line for the paper. And then you basically take the X-Acto knife and go between the two foam pieces that you glued together, and take the X-Acto knife and just follow that line down. That's something you can do, but I kind of think it's an unnecessary step. Again, this wing's super slow flying. It doesn't really matter. It's not going to affect it. You can trim almost all that stuff out, right? So if this is for competition, yeah, I might spend more time on it. But again, for a new person, I wouldn't worry about it. So I am going to tape the leading edge just to make this slightly more durable, but I'm not going to tape the whole entire plane. So if you've not taped the leading edge before, my recommendation is you make sure you got plenty on the underneath side so it doesn't come up, and that when you get ready to fold it over, you go through and cut the underneath side, so that when you bend it, you're not trying to bend the full length of the. Okay, what you're gonna watch me do here is I'm gonna build some extra supports for the fuselage. So this blank that I'm using or this template I'm using is 4 inches by 2 inches. So again, that just makes it easy to do the right angles for the cuts, as opposed to have to set this thing on its side and then trying to make that thing stand straight up and get a 90-degree angle. So again, you don't need this template, but I'll put this in the link. I'll put a bunch of links to any of the kind of templates I have that might help you if you got a 3D printer. But again, not required, just speeds it up, makes it easier, at least for me. Now, others may have a different opinion on this. So you can see this is going to be 12 inches by 2 inches. The other thing that this allows you to do, not only does it add strength, is it gives you a deeper surface to cut into to mount electronics um, in the future, right? So like if you want to give it more protection, strengthen this up, this is a good technique to be able to basically add a ton of strength and then make that fuselage deeper so you can dig deeper into it and have more room without really kind of affecting the structural integrity of the plane all that much. So what I'm going to make here is the fins for the back, and so that's about 8 inches, and it's just a straight line to the top of that point there at the 8 inch mark. So you're not going all the way to the bottom. So basically, what this allows you to do is the reason that I'm not going all the way down there, and you're going to see me put this through this template back in here, is I'm going 1 inch up, right? So what's going to happen is that's going to let this wing, it's going to give the fin a place to hang to basically grab the fuselage with. And so what I'm measuring there is how far um, the distance to the back of the KFM airfoil is. So when it slides up in there, which I think is about 4 inches, maybe 3.5. Right. Then what you saw me do there is to basically take the width of a length of a piece of foam board, and I'm going to cut that out in the future. And then what that's going to allow that to do is to slide over the back of the fuselage. Excuse me, the back of the wing. Again, a lot of doing these quick is just once you cut something that's a duplicate, is to just trace it. And it doesn't have to be perfect, especially anything you're going to sand. And I typically sand the the fins. I sand most fins, and I sand leading edges, and I sand um, elevons and different control surfaces. So again, it doesn't have to be perfect. Just make it close. If I was using balsa or something like that, yeah, I'd probably spend a lot more time on it. But yeah, for foam board, it's not necessary at all, at all. And so what you're seeing me do there is I'm drawing the line by which this will set flush with the um, fuselage, or with the base wing. And again, cutting out that spot for it to attach to the base wing. The other thing that this does, and the reason I kind of use this type of this size, is any place where the the plane kind of you have a single piece of foam that's kind of like not supported, touching the ground, it's an area for it to be weak. So what I've done is I've left enough space underneath there that hangs below the cutout to put a popsicle stick on, right? And then that keeps the popsicle stick will take the most of the brunt. Like you can see that lower piece there is pretty, like there's not a whole lot of support there by itself. But as soon as you add that popsicle stick and then it goes down the length of the whole piece of it, then that becomes a much more rigid piece of a much more rigid piece for the plane. So here, all I'm doing is I'm just kind of sanding down those edges of the wing, that kind of the base that hangs below there. And again, taking those corners and from hard right angles to softer also helps prevent this thing from getting snagged. It strengthens it, right? So it removes some of them weak points from just being exposed. So one of the things that I suggest that you do is when you do this is that you write which side, inside or outside, on these, because it's easy to get them switched around. I've done that before. I've had to put where I've enforced this and stuck it on there. Then I had, you know, like I've taped them different colors to inside and outside, and but had it be backwards when I've done it, because I was just mirroring, or I wasn't mirroring, I was copying, right? And you should be mirroring, yeah, the what those are. So now I know which side, the inside, I know that goes on the inside and it's on both, right? So that's one of the downsides of just like copying stuff is is you got to remember that you have to mirror them as if you copy them, right? So if you, especially anything that has markings, drawings, or any of that sort of stuff, right? So okay, so this is a template that I have that's specific to this build here, right? The purpose of it is to create it, when you see the wing, there's going to be a at the where the motor mount meets, right? It's only one sheet of plywood or foam board thick, right? This will give the motor mount some extra foam to grab onto, and then make it a lot stronger than if it's just a single piece. Yeah, I mean you can do this, if you were doing the cutout and just include it in your cutout, but I always found that harder to do than just using straight lines. So when I built this, I just used Fusion 360 when I drew this out, to for the whole entire plane. I've just basically sectioned this piece off and then made a template to fit in the back. So that when I cut it out, that I could just slide that piece in there. It's going to get covered up anyways when you put the another layer of foam board on top of it. So again, there's a lot of different ways you can do this. I'm not saying that this is the best. This is what works for me. And again, you can do, if you've got a better technique, something that works faster for you or is more logical for you, that's what I would do. So here I'm just going to glue these popsicle sticks on to add this rigidity to the bottom of of the fins. So just a hint here, extend the popsicle stick at the bottom just slightly to the front of the of the paper. Now it does, or the foam board. It kind of doesn't look like that, but that's because of the camera angle. But you want to go all the way up there so that if that thing hits the ground, that the popsicle stick is taking the brunt of the impact. It doesn't really matter. Those things, those popsicle sticks are going to be on the inside and underneath the plane, so you won't even see them anyways. So it's okay if they kind of stick out. Now here's that template that I cut out. Okay, what you see me doing here is I'm pushing, poking holes in the center line so that I can transfer the center line to the top of the KFM2 airfoil. Right? I do this quite a bit. Basically, every time I'm adding a layer, I keep transferring that center line. So like as you start adding components to it, it gets harder and harder to see it just visually and take measurements because you don't always have a bunch of straight angles to go off of. So having that kind of that center line there kind of helps. You got to make sure you're putting things on there equally, lining things up appropriately, that sort of thing. And again, it's also why I keep all the measurements on the bottom side. So if I have to go back and make adjustments, I do have at least some sort of reference point, and I'm not trying to do stuff without, right angles and things like that, where it's easier to make corrections or modifications. Again, you're not going to see this line because I'm actually going to cover it up in the future with another sheet of foam board. So you're going to notice that this is shorter than the full length of the root cord. Um, part of the, part of the reason, or the main reason, is because when you slap the motor mount on there, you need some space for that to grab onto because it's only the type of motor mount that I'm using is kind of designed to only hold two pieces of foam. So a third would just mean you're cutting right into it, right? So, and then here's your measurements for that. It's basically 12 inches by 2 inches. So again, keeping the 2-inch theme, right, for most of your cutouts makes the build process go relatively faster. Could it be 3? Yep. Could be inch and a half. Yep. Just easier to use too. Yeah, I know these are different colors. I just had these already cut out. They're the same length. They're 12 inches by 10 inches, or 12 inches by 2 inches. A lot of times that's what I do with my spare foam is I cut a lot of 2-inch and 12-inch blanks that's left over, or 2 and 6-inch blanks that are left over. Those come in handy for doing stuff like this, making elevons, stacking them on top of one another to create a depth for, say, like a fuselage, like a short fuselage, or to do things like hide your ESCs. You can stack 6 of these on top of each other, one another, sand them down, dig out the center of it, and then put your ESC down in there. So instead of as opposed to just tossing them in the garbage as scrap, it's just a good way to kind of reuse those on and just have them handy. So yeah, that's why these are black and not. I didn't cut these out here. I just had these laying around there. This is not a necessary step, but you can see what's happening is now I'm placing these in between the fuselage, and so again, just making this fuselage incredibly strong and still pretty light. Okay, So now I'm going to start to work on the fins for the back. So first I'm going to kind of dry kind of fit them. You can see now how I've done that, how I've cut those out and slid those in there. Um, the measurement wasn't perfect. I just kind of eyeballed it when I did it, but it's pretty close. And now I'm going to kind of dry fit and cut holes for the servos. One of the things I like about this design is that the servos are kind of somewhat hidden, and the way that they go into this wing, they're kind of supported from three areas, which means they probably won't come out unless you take a real hard crash from the, that would, damage the wing itself. But again, it's completely removable. So again, just going to kind of cut these out. Um, and then the other thing is makes these close to whatever you're hooking to. So you probably don't need servo extensions to get these to whatever you're connecting to, if it's just strictly a receiver or a stabilizer. So at this point, I'm not actually installing the servos. I'm just test fitting them to make sure that they work. And again, I'm sorry that the camera had kind of dropped down here. You can see it's all it's pretty snug, just being friction fitted, not even being glued. So so what you see here is, oh, you can't see it because of the, again, it fell off camera, but I'm basically redoing the cut on from the first fin to the second fin, so that they don't have to go back through and fit it. I'm just going to kind of use the first one as a template to mark it for the second one. So again, speeding this process up a bit. All right, what I'm doing here is I'm taping the wing, not so, or the elevon, not so much for strength per se, but because when the type of control horn I'm going to use, I'm just going to glue on there. It's from a S800 Sky Shadow. So you can use different ones. I just like those because they're pretty robust. I've never kind of had them fall off to a certain extent, unless I left them out in the sun for like a really long time. But for this purposes, it's a simple, it's free, they're easy to use. So what I use the tape because, and I usually try to rough it up a little bit, but then it makes it easy to, it gives a big surface area to hold on to that's not paper, right? if you put the glue to a certain extent can almost kind of weaken the paper on the foam sometimes. So putting that on there, it makes it easy to give a larger surface area to stick to. It also makes it easier to remove if for whatever reason you need to um, remove the control horns. So here I'm going to start gluing. I'm gluing the fins on. Now, I'll say that this doesn't have to be perfect, and it probably won't be perfect out of the gate when you first put the glue on. You've got some options on how you do that. Most of the time, how I help straighten these up is I glue the main piece, and then once it comes time to like finish it up, then I'll insert toothpicks to get it straightened up, and then I'll glue the rest of it, and then that will kind of help keep it pretty rigid. And those toothpicks can stay in there, or you can remove them. I like especially the way that you can see that one of the weak areas of this plane is going to be the very back next to the elevon. So if you take that those toothpicks, push them through, and then leave them in there, but not so much that they go through the elevon, then that'll help kind of keep that back part pretty rigid. And the reason you kind of want to do this is because when you're trying to line up your control surfaces, if that part's bent, it's going to make keeping those control surfaces lined up as you do adjustments for in the future. If you change out batteries, need to do, so you have a crash and this gets thrown off, right? You want that part to be as straight as possible, so it's easier to keep your control surfaces lined up. Again, I'm going to use the toothpicks to straighten these and line these up and give them some strength and rigidity. And apologize that this is off the camera, but what I'm doing is strengthening the underlying sides of the fins with the fuselage with some extra glue. Essentially, what I'm doing here is I'm just breaking off these popsicle or toothpicks. So my template's a little long for this particular build. Um, So now I'm just straightening out or squaring off the mount for the motor mount. Okay, now we're getting ready to do the moving on kind of to the last stage, or one of the last stages, and that is to start preparing to put the electronics on there. So this is the 3D printed motor mount that I was speaking to. So essentially, this motor mount is two pieces of foam board thick. You can, it's slightly angled a little bit, but as soon as you put the hot glue in there, it'll kind of melt it, and you can kind of bend it to kind of fit as needed. Um, because of this motor mount is basically in line with the wing, you really don't need any up thrust or down thrust, which is also another reason that I chose this wing. So by keeping the motor mount in line with the wing, that you don't need to change the thrust angle at all. You can a little bit if you want to put a little down. That'll kind of make it easier to lift. But when it comes to doing motor mounts, where the wing is in the relation to the motor kind of dictates a little bit how much up angle or down angle you need. So with it being straight in line with the wing, you can basically just put it on there and make sure that it's relatively straight. So again, I'm going to use my 4x2 template. Again, eh, this could be 4x3 or it could be 3 inches over. It really doesn't matter. What this allows me to do is not have to take a bunch of precise measurements and kind of eyeball stuff and still be within the ballpark. Um, so what I'm getting ready to do is set the locations for where the control horns will go, and so they're relatively in the same position on both sides of the wing without having to do a whole lot of complex or precise measurements. Sorry. So in this case, I'm going to mount this about 2 inches over from the edge of the inside edge of the elevon, and same thing on the other side. So what that allows me to do is to place the servos in the same spot and then get an idea of how much um, length I need for my push rods. Wait, so I've already got my push rods and control rods. I pulled these off another build. Um, so that's why everything's already together. So I'm basically going to put the glue marks in there for or the glue in there for the servos, pull them through. Now I'm just going to feed through the other side. Now, one of the things that I'll say is where I've made mistakes before, or is I my general rule is, or not rule, but build philosophy is when you're doing the servos, see how they've got the servos aren't necessarily the same on each side. So I always take the side that has the servo lead wire, and I put that the one closest to the center line, or the center of the plane, or closest to whatever it is you're going to hook to, whether it's your receiver or your stabilizer, and I make that side closest on both sides. So that just helps me keep it straight in my head. You could do it the other way around; it really doesn't matter. Just typically try to get them uniform. It'll just save you a bunch of headaches in terms of measurements. So this is going to be the first time we power up actually anything electronic on the plane. And I'm essentially going to use a servo tester to get these and set these at exactly 1500 in the center points, and then adjust everything from there. So this plane doesn't really require any reflex. So the control surfaces for the elevons can basically be pretty much straight with the fuse, or excuse me, with the wing base. Now, if you happen to get an angle in your motor mount or something like that, you might have to change, to add some elevon or whatever, or some up elevator, or down elevator, depending on what happens. But for the most part, if you do everything just basically 90 degrees, you should be fine. So what I do with the reason you see me doing there is to give the glue, some hot glue, some a pattern to grab onto. It's a little rougher than strictly just being um, the tape. So again, this holds really tight, but because it's tape, you can, if you have to spray like alcohol on it, it will help you remove the glue. The alcohol will help you remove the glue, but it won't disbond the paper or anything like that. So, or tear the paper when it comes off. So I found that this is an easy way to put these on here. And then I basically get enough glue, I got it set just long enough to get where the glue starts to set, and then I just try to get the control surfaces pretty level, um, and adjust them. And the way that I'm using my push rod stoppers are the kind that have the 1.5 millimeter cap bolt style, or not cap bolt, what do you call them? Rub screws. So, but that's just what I had handy. I mean, if you don't have this, you can use a very long piece of paper clip and bend it a bunch of different ways to get something similar. But I had this stuff handy, so I just used what I had on another build. So one of the other things I like about these types of push rods or push rod stoppers is that you can they don't have to be exact. You can see that these aren't the exact same length, but because they don't, a lot of push rod stoppers go in between where the control horn and the push rod keepers, and then what ends up happening is they can only be a certain length, because then they start to hit the actual control horn. Right, with these they bypass out to the side, so you have a little more flexibility in the lengths that you use, which means you don't have to cut them exactly to length, and you can reuse them in a lot of different in similar builds. Now, I have a soldering iron here, and it's not to solder anything. I basically use the soldering iron to cut through foam for things like this where it doesn't have to be perfect. What it tends to do is it kind of cauterizes the foam around it and kind of makes it a little bit stronger, and just takes out the need to actually do a bunch of extra cutting. So I want most of the electronics to be below the wing. Um, and so to hide these. Right now you can do this where it goes on top. I just found it easier to put it through the bottom, and to put all the taping and stuff underneath there. Just looks nicer, in my opinion. Again, the main reason I'm putting tape in this particular video, with the exception of the leading edges, it's really to create places where I plan on gluing something to the plane, and it just gives it extra area to grab onto, and then it makes it easier to remove if you have to change something out in the future, right? So if you start adding, you start gluing directly to the paper in small areas that you need to remove, then removing it, later removing it just causes the paper to typically tear. Um, this gives you a good way to kind of be able to modify and add things, take stuff off, move it around to fit your needs, or to actually take tape and tape it to the paper and then remove that tape and then replace it with other tape later on without actually damaging the paper. Again, not a necessary step, but just a good something I do just to give me more flexibility down the road to make updates and changes and repairs. So what I've hooked this to is this is a BIME destabilizer. If you've not flown line of sight before, this is your first plane, then I highly suggest getting a stabilizer. Now, I know a lot of people who have been building planes forever recommend against it, but to me, this, if you spend all your time crashing and none of your time flying, you never kind of learn how to fly. So especially if you're flying on your own, a stabilizer can help you get out of a bad build, right? So if you got the COG slightly off in a manual launch, this will probably send your plane either flipping over backwards or diving straight into the ground because you won't be able to react fast enough. The stabilizer can kind of help give you some breathing room to see if your plane's flying correctly, and then you can get up high enough, flip it into manual mode, and then if it starts to crash, then probably if you flip, especially with this plane, if you flip it into stabilize mode, it's going to self-correct and save the plane from just basically getting destroyed into a crash going 40 mile an hour straight into the ground. So you know, if great if you can fly a line of sight and don't need that help, then all the more power to you. But for people who are new, this is just my what worked for me, my recommendation. So again, the reason I'm going to tape this is that number one, it's going to add strength that's going to go underneath and wrap around, so that helps keep the foam together in a crash. And then the other piece of it is eventually I'm going to stick um, Velcro on top of this so that I can just put the battery on there, right? Um, I'm not overly concerned about the battery flying off because I'm only flying this LOS, so or line of sight. So it's not like I need it to pick up radio signal or something like that. And because the battery flies off, it kind of limits some of the damage that happens to the plane in a nosedive. This Velcro that I'm using, you can use any Velcro, but this is actually Velcro for seat cushions, for fabric. So it's incredibly strong, and it's wide, so you don't have to use a bunch of it. So I think it's 2 inch. I think it's 2 inches. I think two or maybe an inch. Yeah, I think it's about 2 inches, something like that. Maybe a little. I think it's 2 inch. So I cut off about maybe 4 or 5 inches. I've, I know from building these planes about where the battery will go. So it's anywhere between that black strip, just depending on the type of battery you use and motor you decide to go with. So again, a 1300 to a 2000 will work on this plane with no problem. You can get by with an 800, like a 4S 800, but you'd have to move it all the way to the front. On this BIMD, your controller, the first two are to the starting at the right. Looking forward are where your L1's attached. The third rail is for your throttle. The fourth is blank, and the fifth is for your receiver. Now here, I'm having trouble doing this because I forgot that I taped it, so I'm gonna have to go through and put it to punch a hole back through the tape so I can get this through. What you see me here is trying to dry fit and test where the ESC is going to go. I've got relatively long motor wire leads, so I've got some room to play with here when it comes to hooking this up. So now I put a piece of Velcro on there, and that's where I plan on hooking setting the ESC. What I typically do is I'll try to put Velcro before and in front of where I think this might go, and that will give me options to move this around if I have to in the future. So in the field, if something doesn't fly right and I need to push it back because center of gravity or whatever, that's kind of why I'm trying to put it before and after the spot where it goes in. So now we're just going to connect the motor wire weights. What you couldn't see on camera there with the soldering iron is I basically lined up the holes in the where the motor's mounted to the back plate and then to the where actual motor mount on the wing, and I just uh, put starter holes for the screws to go in there. It just makes it easier for it to go in and make sure that it's lined up. There's already holes in there, but they're not super big, so I don't want to crack the plastic or the PLA. Again, these are 3D printed parts that you can that I'll link in the description. Now, honestly, I recommend you take the prop off, but I've done this so many times. I have yet to hit the prop with the soldering iron when I do this, but you should probably have the prop off. I just moved this. I took this off another plane that I decommissioned, so it was already kind of set up, so I didn't feel like removing the prop. But and I guess I admitted the step where I was actually hooking up, putting the receiver on there, but you can see the receivers on the lower right hand corner. And that is an ELRS, I think it's an HLRC flat antenna running S bus, which is one of the is the protocol that the BIMD flight stabilizer uses. So what I'm getting ready to do here is test to make sure the motor's spinning in the correct direction. So you can see the motor spin in the wrong direction. Just simply, if that's the case, just switch to the wires and you should be good to go. All right, so that part's working correctly. And just as for the prop, the big thing is, if you don't know of the pusher prop, the numbers go towards the front of the plane. So it's if the propellers were in the propeller was on the front, then you would have the propeller the numbers on the propellers always point to the front of the plane, regardless of where the motor's mounted. Okay, now I've gone through and kind of started securing things with zip ties so that they don't move around. I've put down the ESC. All right, see that what I'm doing here is I've cut off pieces of popsicle stick and I'm put them on that CG line. That's where early on when we drew that CG line all the way across, we put the markers, the tactile markers, so you know where CG is outside of all the mess of the center of the fuselage, all the wires and all that sort of stuff. So it's just an easy way to get your CG. That CG is relatively aggressive. You can move it forward, but here's So this is what the completed plane looks like. Now I actually took this after I had taken it out and flown it. You see, I had to actually change out the control horns because I broke them, and then that's why I made a mess with the tape because it was dirty in the garage. But essentially, here's your overall measurements: 20-inch cord, 10-inch for the KFM2, 6-inch tip cords with the 3-inch for the KFM2, and then 10 by 2 elevons. Your motor offset is 8 inches or eight inches across, and then 6 inches deep, and then your fuselage is 3 inches, essentially 3 inches, and then that foam piece on top is 10 by 3 or 10, excuse me, 10 by 2. So I got the actual footage cut or inches off on that one. But that's pretty much how the plane is built from start to finish. Again, you can probably do it in 45 minutes. As I kind of wrap this video up, I'll show some just example footage of in-flight and then from like an onboard Instago 360. So. Here's another launch. What I'm doing here is showing you the two different CG marks. Um, the red were the originals, and then the green are the updated ones. It flies on both, but it's a little less aggressive if you move it forward from what's recommended on the in the video. It just seems to fly a little more stable. It's definitely will fly the other way, but you have a lot more elevator in pitch. It's a lot more pitchy if it's too far back. That's all I'm kind of showing here. So you'll see me kind of balance the plane here in just a second. Um, One of the other things you're going to notice here is that the ESC is different as well from what was original build. After my first flight, I crashed, and it was because the ESC I was using burn out and shut the power off, and the plane went into the ground. So it also popped off the control horns. So the changed out the ESC, and it also I didn't do a good job of securing it like I did in the first one, and you can see it fall in the video. But that just happens. So again, I was able to repair this relatively quickly, swap out the ESC, swap out the control horns, and no real damage done. In both cases, you can see in these two examples, the launch is pretty easy, just a slight toss and it's up in the air. It's light, flies easily, launches easy. What you're looking at, just want to show you here is some just onboard footage from a CADOX peanut or slash Instago 360 camera, Instago 2, sorry. You can see it's pretty flies really well in my opinion. You can get low, you can do acrobatics, it recovers well, almost impossible to tip stall, gets low to the ground. So again, I think this is a good first plane for people to build. Yeah, thanks for watching the video. Hope good luck in your builds. And if you got questions, post them in the comments. Thanks again.